Hello, everyone.
Hello.
Hello.
Let's just wait for 2 more minutes. We can probably get started. So Tobias, you will be doing the presentation today, right?
Yes, exactly.
Okay. So
I was asked to introduce KTUP to your tag, and I'm happy and glad to be here to do that.
Okay, awesome. Yeah, so let me stop sharing. You can share. Do you have slides that
Yes, I have some slides prepared for you, so
okay.
I can share my screen.
Yeah, and also it'd be good if you can give us the link after the meeting.
Yes,
okay. Yeah,
I will certainly do that. Yes, of course, not a problem. Okay, so let's get started. So I'd like to introduce KTUP to you. So you see, I pronounce it KTUP, others pronounce it ketchup. It's up to you, however you like. But first, an introduction what KTUP is actually. So it is a Kubernetes backup operator. It is based on Restic, a well-known open source tool in the space of doing backups. And it will handle PVCs and application backups for you on a Kubernetes or on an OpenShift cluster. As already said, I say KTUP, others say ketchup, that's up to you. The project actually started a long time ago, early 2018. The initial name was, we called it the BaaS operator, like the backup as a service operator, because it was all about providing a service for backups so that they are not just run, but we are also confident that they work and that we can be sure that the backups are consistent and actually restorable. So that's why we called it as a service. We had a need to backup PVCs and application consistent data. And back in 2018, the options weren't that given. There were a few projects around in their early phases, but none of these projects meet our needs. So that's why we started to develop the BaaS operator, which is nowadays KTUP. The whole development cycle around KTUP is always based on real world need. So we do what we hear from our customers. We do what we need for our own services. And we also do what the community asks us, what would be cool to have in KTUP. So it's not just someone thinking up stuff which isn't needed. It's really all the features today in KTUP, they are actually born out of a real need in the world of backup and restore. As already mentioned, it uses Restic under the hood, so it doesn't introduce its own backup mechanisms or so. It mainly orchestrates Restic in a Kubernetes and OpenShift environment and basically makes Restic cloud native aware. The current version of KTUP is 2.7.1. The last release was on May 12th. There has been development happening since then, but there hasn't been done a new release. You can find all about KTUP on ktup.io. It's mainly a documentation website, and all the code and documentation and everything else around KTUP is on github.com/ktup-io. We are a CNCF sandbox project since November 2021. If you want to read more about the project state, you can have a look at the not yet approved annual review, but it's there to be reviewed. The idea why we gave it to the Cloud Native Computing Foundation, not just keep it on as a separate open source project or even for ourselves, was that we saw a need to have this kind of tooling in the CNCF landscape. So we didn't find any other tool which talks about or takes care of backing up data or taking care of data in the CNCF landscape. And as we believe that KTUP is a good tool and it has proven its production readiness, and it's also already developed since a long time, we thought it's a good way to spread the word and bring it to a community which cares about these topics. About the adoption, it's a tool which has grown out of our own needs, of our company's needs. So it's used by us for all our products and services. So, we do all backup and restore tasks with this tool. And we know that Lagoon, a tool which is developed by Amazy.io, which is nowadays Emirantis company, uses it for their Zero Ops platform to also offer backup as a service to this product as an integral part of it. We haven't heard of any other Not Vision customers using it, but we are hopefully getting more feedback once the word spreads. So we are open to improve our adoption outside of these two well-known adopters. So let's dive in a bit into the details of KTUP itself. So where does it store backups? On any S3 compatible backend, or rather say it on any Restic compatible backend. So Restic has a huge option of different ways to store backups. Important to know is that Restic always stores fully encrypted data at rest and in transit. So it's not possible to have unencrypted backups. That's why you always have to use a passphrase to encrypt or decrypt the backup data. If you lose this passphrase, you have not access to any backup data anymore. How does it work? So KTUP saves all PVCs in a given namespace. First, you configure the backup encryption secret, which is used to encrypt or decrypt your backup data. Then you somehow have to trigger the backup. You can trigger it one time by using the backup Kubernetes object, or you can set up a schedule, which is the usual case, to have a regular backup up and running. There is no step 3. It's all what you need to have a successful backup. A little example. So this is a absolutely standard 100% upstream conform PVC resource. Nothing special about it. No KTUP specifics, just a plain persistent volume claim. Then KTUP needs a secret for the backup encryption password. We call it here backup encryption. And we need also an access credentials so that Restic can talk to an object storage backend. For example, here we have the object buckets named secret with 2 string datas in it. And this is then used to access the storage bucket. And we define a schedule. In this example, it runs once a day at 4:05 in the morning. We reference the secret where the encryption password is stored, and we reference the secret where the access credentials are stored. We use an endpoint, a bucket name, and that's all. With that object stored in a namespace, KTUP will now automatically every morning back up all PVCs which are in this namespace. But you might have heard of Schrödinger's backup. So if we don't do restores, the backup might not exist. No? That's why KTOP has first-class support for restores as well. So the one way to restore data from a KTOP RESTIC backup is to use the restore object, where you say which snapshot you want to restore. To get a list of available snapshots, you can either use RESTIC itself, the tool, or you can use the snapshot object in the Kubernetes cluster, which gives you a list of available backups in the backend. You then say where you want to restore it. In this case, we just use another PVC to restore the data into. And once again, we have to reference the password and access credentials for the buckets, and then wait a few minutes and your backup is restored there. The second option, yes?
Excuse me, may I ask a question?
Yes, of course, just go ahead.
So in this case, are you only restoring one PVC? Because it gives the one claim name? I
restore what's in this snapshot ID, and
right,
I restore it into this PVC.
Right, so that means there's just one volume being, one PVC being snapshotted. It's just like...
Not exactly, it's just...
because otherwise, how can you keep one claim name if you have more than one PVCs being snapshotted? That's my confusion.
Yes, I see.
Yeah.
Yes, I see. So what I didn't mention before is that KTOP iterates over all PVCs you have in your namespace and backups all of these PVCs. It tags them. So RESTIC has a way of tagging backup snapshots. And when I then want to restore a certain PVC from this namespace, I have to look up in the RESTIC snapshot what's available in this snapshot, and then reference this snapshot ID I want to restore. I just give one PVC where I want to restore the backup into.
Okay, this is like one particular snapshot of one particular PVC, basically.
Yes, exactly. Exactly. So what you see,
like a backup. It's not really from a backup job. It's not like that. Okay.
Yeah. So what you see in the next slide here is that you can also use RESTIC bare bones without KTOP. It's just to show you that KTOP, your data isn't tied to KTOP, it's tied to RESTIC. So you can also use the RESTIC tool bare bones to restore the data because it's RESTIC data. And when you configure RESTIC with these 4 parameters, you need to access the backup backend. You can then issue the RESTIC snapshots command, and this will give you a list of available snapshots. And in this case, it's just one snapshot displayed, and the host name actually is the name of the PVC. That's documented somewhere in the KTOP. So documentation. So if you have multiple PVCs in a namespace, you would have multiple snapshots here per PVC, and then you can choose the one you want to restore by then referencing this snapshot ID, what we do here. And you would use this snapshot ID in the former example here, you would put in this snapshot ID here, and then it would restore this PVC, and that has this data, this directory stored to this other PVC we referenced here. This can also be a different PVC. It doesn't have to be the same PVC. Usually we do restores into a different PVC so that we can check data and copy it around to be sure that we don't override any existing data which shouldn't be overridden.
So when you
does that answer your question?
Right. For this, when you decide what to backup, so you said the backup everything in the namespace. Can you also select just some of the PVCs in that namespace, not every PVC in that namespace?
Yes, that's also possible. Yeah, we can. So KTOP was developed with that in mind, that we don't want to lose any data. So the current situation of KTOP is an opt-out. So if you don't want a PVC to be backupped, you have to opt out from the backup by adding an annotation called ktop.io/backup false. But you can configure KTOP to work the other way around and say, you have to opt in for the backup. So it won't backup any PVC unless it has the annotation ktup.io/backup true. So you as an administrator of the KTUP operator can choose how you want to have KTUP behave.
Okay, thanks. I think there's a question from Rafael.
Yeah, I have a question. When you take a backup, do you do something to the application to stop the I/O? Usually it's called quiescing the application.
Yes, that's also possible. In this normal or simple case, I would call it, we just back up the data from the PVC and do nothing else. But when we come to the next slide here, we also have a possibility to have pre-backup pods, which do something to quiesce the data or to make sure that the data is application consistent, we call it that way. So in this case, we call MySQL dump to dump the database, not just copying the file away, but also do a database dump before. And there are two ways to do that. You can either have a pre-backup pod, which on schedule gets started, this command is executed, and then made available to KTUP RESTIC to backup. Or you can also use an annotation in your already running pod to, for example, run MySQL dump, and then it streams the data via standard out and standard in to RESTIC so that the pod continues to run. Yeah. So that's this one on the next slide. I have it here. So you can add this annotation to your pod template in a deployment or in a stateful set. And when KTUP schedules its work, it will run this command, and everything gets streamed via standard out, standard into RESTIC, and then stored into the backup. So it actually hooks into the pod via the Kubernetes API and runs this command inside of the pod and streams the output via standard in, standard out.
So in this case, we are backing up the volume and the output of this command. Is that?
You can do that. Yes, of course. Yeah, that's true. So but maybe it depends on what you want to do. If you do it that way, I'd rather do not backup the PVC as well, because then I have duplicate data backups.
Okay. So you can just do the command. Okay.
Yeah, maybe you want to have both to be very safe on all edge cases and so on, but that's up to the user of this backup. Yeah.
Understood. Thank you.
So there are some other features I want to showcase quickly. So we can also have a regular check for data sanity using RESTIC check. So this actually makes sure that the backup repository is sane, so that there is no broken data in it. We also do backup rotation with RESTIC prune, so that you can configure how much backups you want to keep, so to not blow up your backup storage backend. We also have a backup archival feature, so that allows you to save a snapshot of your backup to a dedicated location like AWS Glacier, for example, for archival. So what this actually does, it does a restore, saves that restore in a tar GC, and stores that tar GC in, for example, AWS Glacier for 10-year, 20-year retention or whatever you have to use back then. We also have a lot of Prometheus metrics because we want to know what's going on, how many files have changed, how many errors have been, how many backups are available, and so on and so forth. So there is a lot of observability inside of KTUP already. And we also have webhooks, which can provide information about backup to another backend, for example, a user interface or whatever, so that the user can see what snapshots are available, for example. The latest feature which have been developed this year is, as already mentioned before, for a restore, you have to know what snapshots are available. And it was a bit cumbersome before. You had to use RESTIC snapshot list to get a list of snapshots. And today you can type kubectl get snapshots, and then you get a list of available snapshots, and then you can dive into these custom resources and see the details of these backups, so that you have all the information in your Kubernetes cluster at hand, so that you don't need any external tool to do the restore and see what's available. We started to develop a KTOP CLI to make things easier. Before this CLI, you had to do YAML engineering. And with the CLI, you can type your restore command, and then it generates the YAML for you in the background and provides that to Kubernetes cluster so that the restore works. Today, it can only do restores, but you also want to have other features developed into the KTOP CLI to improve the user experience when working with KTOP. We also found a way to do good backups of RWO volumes. The issue there is that usually you cannot mount an RW PVC onto another node. When a workload is running on node A, you cannot run the backup pod on node B because it can then not mount the PVC onto the other node. And we now figure out on which node the pod is running, where the PVC is mounted to, and schedule the pod onto the same node so that we can mount the PVC into the RESTIC pod so to actually store the data. This will be a bit problematic in the future. There is a new mode available which makes sure that PVC can only be mounted to one pod and exactly one pod, and then we have to find a new solution how to do that once this gets used more and more. We did a lot of internal rewrites because of historical reasons. You see that the project is already 5 years old. We had at least 2 rewrites when we started. Back then, we started with the Cooper framework to do Kubernetes operators. Then we rewrote it with the operator framework from Red Hat. And nowadays, it's plain Kubernetes framework usage. And we had to do a lot of cleanups from the past. I mean, the code base has grown a lot. We have a few plans for the future. So we actually do really want to onboard more maintainers than just us. That's hard. We get peers. We got peers from outside contributors lately and also issues, but not that much yet. So we hope that to increase the visibility in the community so that we can onboard more maintainers to make KTOP the best backup solution on Kubernetes. So the other plan is to increase adoption with stuff like having a KTOP kiosk on the CNCF or on the KubeCon, Cloud Native Con. We had one this year that was very, very successful. People were interested in the project very much. Plus showcasing it to groups like you are. That's important to us to spread the word about the project. Then when the adoption raises, we are pretty sure people will find issues and bugs and stuff like that, which we haven't saw in the past or haven't thought about. And we want to tackle them to make it a rock solid and fully reliable data protection tool. That also means fix annoying bugs, which are being discovered while the adoption raises. Plus, on the technical side of things, we do have to do another round of renewal of operator patterns. Currently, most of the configuration of the global configuration of the KTOP operator happens via environment variables and command line flags, which you don't feel like to be very cloud native. We also want to use the native Kubernetes cron job for scheduling the backup jobs. We currently have a homegrown solution because also of historical reasons back then in 2018, cron jobs in Kubernetes weren't that great. Nowadays, they are seen to be stable. So that's now a chance for us to get rid of some code and use Kubernetes cron jobs for that. Also, we want to have simpler RESTIC repository configurations so that it can be reused by different schedules. The CLI tool enhancement I've already mentioned before. And we also want to be able to have multiple different backups per namespace. Currently, you can have one schedule object per namespace, and then this applies to all the PVCs or backup commands in this namespace. We want to be able to do label selectors to be more flexible there. Yes, so that was the run through KTUP. You already had some questions. Do you have any more questions?
Yeah, nice presentation. Thanks. So I know that Velara also supports Restic. I wonder how is this different from that?
So there are a few technical differences between how KTUP does backup and how Velero does backups. For example, Velero works on the host level. So they have a daemon set running on every node, mounting storage directly on the node, and then do the backups. And we do it fully cloud native, I would say it like that, or Kubernetes native, because we do not run any daemon set which it works directly on the host. It all works on the pod level. So that's the difference in terms of technology. And we did that because we are using OpenShift heavily, and it wasn't possible to run Velero back then on OpenShift. Nowadays, I guess it works. But that was one reason why we still are developing KTUP. And another reason is, I don't know how it is today, but back then we needed a lot of observability in how backups are doing, and that wasn't available with Velero back then. So to only name two differences, but there are certainly more, of course. Yeah.
Sure, thanks.
If you don't have a daemon on the server, is it possible to integrate to do like a database backup?
You mean with KTUP? Yeah.
Yeah, like if you have like a Postgres or MySQL running on the servers, is it possible to like integrate with a database?
Yeah, that's possible with the pre-backup pods. Yeah. So you can run whatever command you like, and you see in this example we do a MySQL dump and are connecting to this mariadb.example.com. So in this case, we are connecting to an external database running somewhere in the cloud and dumping this data with KTUP in a Kubernetes cluster.
So you basically remotely do a SSH to do this command?
No. Oh no, that's via the Kubernetes API. We do an exec into the pod.
Oh, okay, it's API. Okay.
Yeah, it's all no SSH, no nothing. It's just plain Kubernetes API.
Okay.
Any other questions?
So I believe with the Restic, you have to mount the volume for you to read data, right? So let's say if a volume the PVC is not used by a pod, there isn't a way for you to really back that up, right?
That would be that you would have to do with the pre-backup pod as well. No. That sorry, I just had the wrong thought in mind. It is still able to do a backup for an unused PVC because KTUP starts its own backup pod and mounts this PVC in the backup pod. So you can back up unused PVCs, yes.
Okay.
Can the backup destination be another storage class PVC that gets dynamically provisioned?
So you, maybe not. I'm not pretty sure if it works. Usually, so Restic has different compatible backends, and it can also back up to another file system path. So it should be possible, but I'm not sure if we support it in KTUP yet. But it's a good idea, yes. So maybe open an issue on GitHub and ask for that. That's a good idea.
And then you said, is this you have customers using this?
Yes. So maybe what I missed to say, we originally developed it for the Australian government back then. The Australian government has a GovCMS. That's a tool they offer for their different agencies, government agencies, to provide websites to the Australian people. And Restic or KTUP is doing backups there since 5 years, so in production. So yes, it's used in production quite heavily. And we are using it also since 5 years as the default backup solution for all our products and services we are offering to our customers.
Because one concern I heard about Rustic is the performance, because it takes a long time. Yeah, so are there any customers having problems with that?
We had problems, yes. But Rustic has progressed. So they, I guess in Rustic 0.14, I'm not sure again that they did a huge performance boost. So they did some internal refactorings which boosted the performance a lot. That's true. So what I didn't mention is we are thinking of, but that's not really planned, but we have an idea to also support other backup backends. So currently it's Rustic, but we could also support Borg or whatever other backend. We are not really tied to Rustic. I mean, it could also use another Borg, for example, another tool to actually run the backup itself. But it's not on the plan yet. It's just in our heads and while talking during coffee time.
Yeah, sounds good. Thanks.
Yeah. Any other things I can tell you about KTOP?
So you said right now the contributors are from the same company and you're trying to grow?
Yes, exactly. That's true.
Okay.
So we have outside contributors also from Amazee.io doing some pull requests, but not that much yet. But we would love to be able to enable other people to contribute to KTOP. So we are very open to that.
And then you said this is only for OpenShift, but this is for vanilla Kubernetes.
No, it's for all. It's for all.
So it should be for all the.
It's for Kubernetes or OpenShift cluster. We mention OpenShift here. I mean, OpenShift is yet another Kubernetes distribution, but it has its own tightness with in concerning security and what you can do. So we mention it here to say yes, KTOP is compatible with OpenShift, but it can be used on, and it is used on EKS, I know, on AKS and then GKE. So it's already used on different cloud providers today.
Yeah. So probably what you mean is you yourself, probably you just qualify on OpenShift, but it should, in theory, it should work on all the distros, right? That's what you mean?
Yes, in theory, but also in practice, because we know it runs on, I know it runs on K3S. It runs on RKE from Rancher, from SUSE Rancher, and it also runs on GKE, AKS, and AKS. So it runs on all the major cloud providers, and we have customers running it on it. So we know that it works.
Okay, thanks. Are there other questions for Tobias? Okay, looks like we're all set. Yeah, if you can share this.
I can send it to you in Slack.
Yeah, that would work. Yeah, that would work. Yeah,
it will be tomorrow for me because.
Oh yeah, no rush. As long as we have it.
I will send it to you. Yes, of course. Yes.
Okay. Yeah, sounds good. Yeah. Hey, thank you very much for the presentation.
Thank you for your time. Very if nice. You have any other questions, you know where to find us.
Yeah. Yes, of course.
Thank you, Tobias.
Thank you.
No worries. It was a pleasure showing it to you.
Yeah. Bye.
Bye, everyone. Have a nice one. Bye.